So this video is for all university students who have taken a course in financial mathematics. The type of questions that we'll be using here, they are mainly from UNISA, which is University of South Africa. But nonetheless, if you are at the university level and you have registered a course in financial mathematics, this will be very much helpful for you. Now, the questions that we're going to look at, the first question, which is question 1, reads, you have to determine the equivalent continuous compounding rate corrected to 2 decimal places of an interest rate of 17.5% per year compounded quarterly. To make the video short, let's go straight to the question. So if you are a UNISA student, a formula sheet will be provided to you. I don't know if you are studying with various institutions, but at the end of the day, the choice of formula to use is this one, whereby the variables that are given here, the JM is for interest rate, the M is for compounding period, the very same M is the very same M that you have here, and the C is the continuous rate that you need to determine in this case. So now, before you approach this question, you know that you are given the JM, which is 17.5% for this case, and the M is the continuous period, which is quarterly. And quarterly means M is equals to 4 because we have 4 quarters in a year. Now, just to make you understand, these are the variables given. JM is 17.5%, and then M, which is the compounding period, is 4 because we have 4 quarters in a year. Now we have to calculate what? C. Now to do that, you can just substitute the values you have here, substitute them here. But then for you to substitute the interest rate, you must first divide it by 100. So if you divide it by 100, it means this is going to be 0.175. That's the value that you're going to substitute here. But before you substitute, the best thing to do is to make C subject of the formula, playing around with your mathematics. Let's do that. Now, if I want to make C subject of the formula here, it means first I'll divide by M both sides. If I divide by M, obviously this M is going to cancel that. So I'll be left with E C over M minus 1 is equals to JM over M. And then I will take the 1 to the other side of the equal sign such that it will changes and becomes a positive because it was a negative. So I'll have C over M is equals to JM over M plus 1. But in this case, I need to make CM subject of the formula, meaning I will introduce linear arithmetic for both to remove the E. So we'll have ln of E C over M. What I do on the left-hand side, I also do on the right-hand side, meaning I will have ln of JM over M plus 1, like that. And then for this now, let me just get rid of this. Now from here, I will take the C over M to the back. Now I'll have CM ln of E. Now there's only 1 left here because I took it to the other side. This is going to be equals to ln of JM over M plus 1, like that. Therefore, ln of E to the 1 is just going to be 1. So this part here becomes 1. Even if you punch it on your calculator, you'll find that this is equivalent to 1. So your formula now will look like C over M is equals to ln of JM over M plus 1. And then because I want to calculate C, I will cross multiply the M to that side because this one is over 1. The 1 will go that side such that the final formula will be C is equals to M ln of JM over M plus 1. Now, if you don't know how to convert from here to here, the best you can do for yourself is that while you are preparing for your exam, you can just memorize the formula such that to move from here, it looks like this. And then from here, I will divide all the given information. Therefore, C is going to be equals to, I know that the compounding period is 4. So 4 ln of JM is given as 17.5%, which when I divide by 100 is going to be 175 divided by 4 plus 1. Whatever I get here will be the value that is needed. So now when I punch this on a calculator, I will get that. And as you can see, I am able to punch it exactly as it is on a calculator. The way the formula looks, I punched it exactly as it is on a calculator like that, such that my final value to the nearest is going to be 0.1713. So 0.1713, if I multiply it by 100 again to take it to percentages, it means this is approximately 17.13%. So this means that the compounding period for 17.5% compounded monthly is 17.13%, like this. Now, that's it with the first question. The second question goes, if 35,000 accumulates to 48,320 at a continuous compounding rate of 8.6% per year, determine the term under consideration in years to 2 decimal places. So now you are given the future value and the present value. You have to determine the term it took for the investments to get to that future value. Again, if you are a UNISA student, this one is mainly an advice to UNISA students. But also with any other university level or university institution you go to, if you know your algebra is bad when coming to playing around with what you have to calculate, it's very much advisable that you practice that before you go to the exam so that you know all the shapes of the formula, how they look like based on the variable that you have to calculate. But otherwise, let's go to it without wasting time also. So this is what we're going to have. So on your formula sheet, if you are given the present value and the future value under continuous compounding, the formula of choice that you're going to choose is this one. S is equals to P ECT, like this. And in this case, we have to calculate the term, and the term which is now our T. Now, from here, you can go ahead and substitute all the values that you have here, because you have the future value, you have the present value, and you have the compounding interest rate. But now, let's make T subject of the formula first before we substitute. So I will divide by P both sides. If I divide by P both sides, obviously this will cancel that. Therefore, I'm left with ECT is equals to S over P. But because I want to make T subject of the formula and it's on the exponent, I will then introduce ln again. So I'll have ln ECT is equals to ln of S over P, like that. Therefore, I'll take the CT to the other side because I want to make T subject of the formula. So I'll have CT ln of E, and then there remains 1 because I've moved the CT to the back. That's the rules of exponents, or linear arithmetic rather, same as logarithm. Therefore, this is the same as ln of S over P. But then, like I say, ln of exponent 1 is just going to be 1. Even if you punch it on a calculator, you can tell that ln of E to the exponent 1 is 1. Therefore, this means my new formula is going to look like CT is equals to ln of S over P. This is just the algebra, guys. If you can't do this, just make sure you practice this and then you memorize the formulas if you can. But at the end of the day, you have to do it like this. And then we're going to divide by C both sides because we have C, which is the compounding rate. Therefore, T is going to be ln of S over P over C. Now from here, I can substitute the values that I have based on the question. Therefore, T is going to be ln of the future value, they said is 4,320 over the present value. He invested 35,000, like that, all over. The compounding period rate is 8.6. But since I have to represent this in years, and any other time I'm using any of the formulas of mathematics, under financial mathematics, I must make sure the interest rate is divided by 100 before you substitute. So 8.6 divided by 100 is going to be 0.086. And then from then, you can punch the whole value that you have on your calculator. You can key it in on your calculator as it is to determine T. Now, T will be, again, the calculators that we use today are able to punch in a fraction as you see it. So now, as you can see here, the way it is presented, that's how I've keyed it in on my calculator. So the answer is going to be 3.75 years. So it means for 35,000 to accumulate to 48,320, it took 3.75 years. So the term is 3.75. That's how it goes. So from my experience, in most cases, students will take this module, which is DSC 1630, that's the module code, but then the module code can differ based on the institution you go to. They are not really big on algebra like that. So it's very much advisable that you practice how to play around with your formula in terms of the variables that you have to calculate. Thank you for watching. Don't forget to subscribe to our YouTube channel and follow us in all our social media platforms such that you're going to have to see more questions like this. I'm Mr. Maimane. This is Simplified RSA. We are the guys who makes it look easy. Thank you.